My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 537. In this lecture, I will continue my discussion on multi-layer perceptron. I request you to go through my previous lecture, that is lecture number 536, before understanding this lecture. There is also a nice mathematical argument, very interesting mathematical argument, actually very simple mathematical argument. So to understand this mathematical argument, we will divert slightly from the core discussion. I will explain this with an example. So let's take a regression problem. Let's take a problem of regression. What's the problem of regression? Given data set capital D xi comma yi, we have to determine function, let's say capital F, that connects with xi's and yi's. This is a task of regression. You want to find function capital F that relates xi's with yi's. That's the problem of regression. Again, your yi belongs to R. So let's take regression for simplicity because it is easy to understand regression and classification for this argument. So let's assume this is my x-axis. I have x-axis as well as y-axis. I am given some data set xi comma yi, that is my capital D. Let's plot 2 into sine x square plus under root of 5x, isn't it? I would like to plot this one. This is the function, yes, 2 sine x square, 2 sine x square plus square root of 5x. Let's assume your xi belongs to R, yi belongs to R. When I plot my xi comma y, when I plot my xi's and yi's in my data set, it's look like this. It's look like this. If I plot this one, my plot looks like this. Let me assume like this, isn't it? Yes. What is my task in regression? My task is in regression is to find capital F of x. You have to find capital F of x which connects my xi's to yi's. This is a task of regression. When I plot it, when I plot this data set, it looks like this, isn't it? It's a very easy to plot. Now the question is, how do I come up with this function? Okay, let's say case 1. If my case 1 was capital F of xi equal to, let me consider case 1 is f of xi equal to xi. So if I say yi equal to xi, what is this? How will this plot looks like? Y equal to x plot, yi equal to xi plot means this plot looks like 45 degrees line. Of course, some points are here close to this line, and but there are lots of points where the error is lot. So your function is far more complex than a simple line, isn't it? If I want to plot a simple line, if I do a simple linear regression on xi and yi, probably the line looks like this. If I am doing simple linear regression on my data set capital D equal to xi y, but linear regression is not sufficient because you see there are points xi, there are points xi, yi, pairs of points here. Just see here you have pairs of points. This you have pair. There are points like this, isn't it? So these points are away from this particular line, isn't it? Regression line, linear regression, isn't it? So what do I do? Simple linear regression is not working. Of course, you can go to random forest, all of those things, but let's try to write it in functional form. We want to find capital F which connects xi and yi. My capital F of x, what is my capital F of x here? My capital F of x is 2 times, what is my capital F of x? 2 times sine x square plus square root of 5x. This is the actual function from which I plot this graph, isn't it? It's a very complex function of x. So there is a trigonometric function. What is my trigonometric function? Sin x square. And square root function. Why? Because under root of x into 5. There is a square function. Why? Because sin x square means there is a square function x square. There is a multiplication function. 2 sin x square means 2 is multiplied with sin x square. There is an add function. You are adding 2 sin x square with square root of 5. Isn't it? There is an add function. There are lots of functions here. So let's try to understand why multi-layer perceptrons are powerful from this example of regression problem. So let's go step by step. So let's assume I have a function f1. Let me say I have a function, just let me assume I have a function f1 which is an addition function, which is an add function. Let's assume I have function f2 which is which compute square of a number, Let's assume I have function f3 is a square root of function. My f3 is square root of function, and let's say my function f4 is trigonometric function, that is sine function. Let's say my function f5 is multiplication function. Now using these functions, can I construct, using these functions, this point is important, using these functions can I construct this function capital f of x equal to sin x square plus under root of 5x, isn't it? Larger function I can construct. Let's see how to do it. Imagine I have x as an input. Imagine I have x as an input. 5 is also input. Just assume here I have input. Which one is input? X is input. 5 is also an input. I can first multiply x and 5. I can multiply x and 5. I can have multiplication unit here. So what is the output of this? Output of this is 5x. If x goes to inside this, and 5 goes to inside, output is, what is your output? Output is 5x. The output here is 5x. Similarly, I can use function square, and I can use function square. I can give input x to this square function. Just I am giving input x. Just see this one. I am giving input x to the square function. What is this output? Your output will be I get my output here is x square, isn't it? So what is the function that we have? F of x equal to, what is the function? 2 sin x square plus under root of 5x. Now we can construct this complex function. It's a very complex function. This is very complex function, but you can construct this complex function using multi-layer perceptron like structure. So here I have x square. Just see, here I have x square. Now what I have to do? What is the next operation? Let's say I do sine of this. Just see, I am doing sine of this. What do I get now? My output here is sin x square. Now I can also input to here. I can also give input number 2 here and pass both of them to multiplicative function. Here I am passing this 2 and sin x square to multiplication unit. What is the output here? The output I get here, the output is what is 2 sin x square, isn't it? I have 5x here. Just see, I have 5x here. Now I pass through this function through square root function. If I pass through this function with the square root function, what will I get? I will get root 5x. Now I take this output. And this output. After take this output, these both outputs, if I pass through an addition function, just see, I am sending these outputs, this one and this one, to addition function, isn't it? Now what do I get? Here finally I will get 2 sin, that is my yi cap. Y cap is equal to 2 sin x square plus root 5x. Now this is my yi cap. What is my yi cap? This is my yi cap, isn't it? This is my yi cap. So we have seen multi-layer perceptron. I have inputs here and I am passing through these inputs through sequence of functions, isn't it? I am passing through these inputs through sequence of functions. Here I have functions, isn't it? If my functions here is sine, multiplication, square root, extra, isn't it? Yes, f of x equal to, what is my function? F of x equal to 2 sine x square plus square root of x, isn't it? Now this is what happen if multi-layer like structure. So this is multi-layer like structure, isn't it? So this is your input. What is your input layer in multi-layer structure? This is your input. You have input layer. Just observe, this one is input layer, isn't it? This is output layer. This is output, which we discussed, isn't it? We already discussed what are the hidden units. You have here, you have hidden units. So by having this multi-layered structure, we can come up with complex mathematical functions to solve our problem. If your data set is generated from this, if your data set is generated here, if you observe this one, I have input layer, output layer, and output function. If your data set is generated, just I am comparing this particular structure with previous lecture structure. As I told you, here you have input layer, output, and hidden units, isn't it? This particular, if your data set is generated, from this function, which function? This is the function which we discussed. If your data set is generated from this function, what will you do? Having this multi-layered structure, giving you enormous power, because you can come up with complex mathematical functions to solve your problem, to solve your regression problem in this case. So the multi-layered perceptron structure, the multiple-layer structure, the multi-layered structure gives you enormous power to your models, because look at it. If you recall our discussion about overfitting and underfitting, linear model is the simplest model. If your data is non-linear like this graph is non-linear, this data is non-linear data, isn't it? If your data is non-linear like this is not linear data and linear data at all. Having access to more powerful models or more powerful class of functions enables us to solve much harder problems. Linear regression is simple linear model, logistic regression is simple linear model for classification. Having non-linear models, we discussed about non-linearity and how to create non-linearity using RBF, using SVMs. We have seen this because random forest and all decision trees and GBDTs can create non-linearity. Here we are creating non-linearity. Here we are creating, just see, here we are creating non-linearity through sequence of functions, by applying sequence of functions, which is very powerful. Now equally importantly, this is very similar to the concept that we learned in high school. Just I request you to go through this lecture, and if you have any difficulty, please keep a comment. I will continue my discussion on multi-layered perceptron in my next lecture also, that is in lecture number 538. Thank you very much.